What if I tell you that a storm 3 times the size of Earth is slowly disappearing before our eyes? Well, that's what the recent data from the Apache Point Observatory in New Mexico revealed, creating a stir in the astronomical community. This phenomenon is unfolding on Jupiter, where its iconic Great Red Spot, a massive storm raging for at least 400 years, is showing signs of diminishing. Once large enough to engulf 3 Earths, this giant is now shrinking, altering our understanding of the Jovian atmosphere and challenging long-held assumptions about planetary weather systems. The Apache Point Observatory, utilizing its powerful telescopic capabilities, has been monitoring this unprecedented change. Their findings contribute to a growing body of evidence suggesting that we might be witnessing a historic transformation in Jupiter's atmosphere. As researchers continue to analyze this data, the question arises, what could be driving this dramatic alteration in one of the solar system's most iconic landmarks? The discovery of this Great Red Spot was an extraordinary moment in the history of astronomy. The Great Red Spot, with its distinct red hue, is a captivating mystery to scientists. Now let's talk about the sheer size of this storm. To truly grasp the scale of the Great Red Spot, imagine not 1, not 2, but 3 Earths placed side by side. Yes, that's the approximate size of this storm, a turbulent expanse larger than our entire planet. The wind speeds within this tempest are beyond anything we experience on Earth. Gusts can reach a staggering 400 miles per hour, far exceeding the intensity of the strongest hurricanes we know. Yet as we marvel at the grandeur of this celestial spectacle, we must also remember its transience. For all its size and strength, the Great Red Spot is not eternal. It's been shrinking over the years and may eventually disappear. That's right. A single storm larger than our entire planet has been raging for centuries on Jupiter, but it may not last forever. Since the late 1800s, the Great Red Spot has been shrinking. Today, it's only about 1/3 of its original size. This colossal storm, once 4 times the size of Earth, has now been whittled down to a mere 1.3 times the size of our home planet. Isn't that something? The shrinkage of this giant storm isn't just an overnight event. It's been a gradual process, painstakingly tracked and measured by astronomers over the years. Comparing images and data from the late 19th century to the present day, it's clear that the storm has been steadily losing steam. The spot was about 44,000 kilometers wide in the late 1800s, and now it's dwindled to just under 14,000 kilometers. But what's causing this dramatic change? Well, there are a few theories floating around. Some scientists believe that changes in Jupiter's climate may be playing a role. You see, climate isn't just an Earth thing. Even gas giants like Jupiter have their own weather patterns and climate changes. It's possible that shifts in Jupiter's atmospheric conditions could be causing the Great Red Spot to shrink. Another theory points to disruptive currents on Jupiter. The Great Red Spot is essentially a high-pressure region, and if lower-pressure currents disrupt this region, it could cause the storm to lose energy and shrink. But the truth is, we don't really have a definitive answer yet. These theories are based on our current understanding of Jupiter's complex atmospheric dynamics. But with a planet as mysterious and distant as Jupiter, there's always more to learn. And that's the beauty of it. The Great Red Spot's shrinkage is a puzzle, a mystery that's yet to be fully solved. One of the most iconic features of our solar system is disappearing, and we're not exactly sure why. It's a reminder of how much there still is to discover, of the vast and uncharted territories that lie beyond our earthly home. And that, my friends, is the thrill of astrophysics. If the Great Red Spot continues to shrink at its current rate, it could disappear completely within our lifetime. This might sound like a bold statement, but it's not one made lightly. Based on current trends and careful observations, scientists predict the future of this gigantic storm could be on borrowed time. But what does this mean? Well, at the current pace of shrinkage, the Great Red Spot might morph into a circular storm by around the year 2040. And if the trend continues unabated, we could witness its complete disappearance by as soon as 2080. This isn't just a dramatic transformation of an iconic feature, it's a potential game changer in our understanding of Jupiter's atmosphere and climate. Now, why does this matter? Simply put, the Great Red Spot isn't just a pretty face. This massive storm, larger than Earth itself, plays a significant role in Jupiter's atmospheric dynamics. It's like the beating heart of Jupiter's weather system, pumping heat and energy around the planet. So its disappearance could have profound implications. If the Great Red Spot disappears, we could see radical changes in Jupiter's atmospheric patterns. The redistribution of heat and energy could lead to new, possibly more volatile weather systems. It might even affect the color of Jupiter as we know it. The gas giant's iconic reddish hue is largely due to the Great Red Spot's influence. Without it, who knows what color changes we might see. But the disappearance of the Great Red Spot isn't just about Jupiter, it's about our understanding of the universe. It would force us to re-evaluate our models of gas giants, their weather systems, and their atmospheric dynamics. It's a reminder that even the most seemingly permanent features in our universe are transient and subject to change. The disappearance of the Great Red Spot would not only change the face of Jupiter, but also our understanding of the gas giant. Great Red Spot isn't just a storm, it's a window into Jupiter's complex and dynamic atmosphere. For centuries, this colossal storm has been a beacon for scientists studying the largest planet in our solar system. With winds reaching breakneck speeds of over 200 miles per hour and a size so vast it could swallow Earth 2 times over, the Great Red Spot is a phenomenon of epic proportions, but what makes it truly remarkable is the unparalleled insights it has provided into the atmospheric dynamics of Jupiter. The Great Red Spot is a high-pressure region, a stormy vortex of swirling hydrogen and helium, tinted red by unknown chemicals. Studying its swirling patterns and color variations, scientists have gleaned valuable information about the planet's composition, temperature gradients, and wind patterns. By observing the storm, we've learned about Jupiter's atmospheric layers, the depth of the storm, and the speed of its winds. This data has been instrumental in developing models for the planet's overall atmospheric circulation. The storm's longevity, its resistance to dissipating, further adds to its enigma, offering scientists a unique opportunity to study atmospheric persistence and stability. Moreover, the Great Red Spot isn't just a key to understanding Jupiter, it's a tool for comprehending weather on other planets as well. By comparing the storm's dynamics to those on Earth, we've gained insights into how weather systems can evolve on different planets, enriching our knowledge of planetary atmospheres beyond our own. The potential disappearance of the Great Red Spot therefore carries significant implications. Losing this astronomical marvel would mean losing a valuable tool for studying Jupiter, a treasure trove of information and a stepping stone for understanding the broader universe. So, you see, the Great Red Spot is more than just a storm on Jupiter. It's a key to unlocking the mysteries of our solar system. It's a symbol of the enduring quest for knowledge, a testament to the ceaseless wonders of the cosmos and a reminder of how much more there is to explore. And if you like this explainer, we believe you would also enjoy the video shown on your screen right now. Click on it and let's catch up there.